This video is hopefully going to show how you can use the plasma cutting add-in developed to set up a robot to do plasma cutting or path following and show you kind of all the nuances that go with it. So first off, obviously you're going to need robotstudio open from there. After you've done that, before we go any farther, we want to check and make sure that you have the plasma add-in loaded. Now, the way you're going to be able to see that is if we go to the add-ins tab, there will be a whole bunch of your add-ins located right here. You'll notice that there is not one saying anything about DXF or Plasma or anything useful. So if we look right here, you'll also see it not referenced. I do not know if the add-in will actually be available here in the gallery. So there will be a link down in the video that will get you to an area that can download it. Once again, this is for my own internal use. So given that I will most likely not be upkeeping it beyond my needs, but you guys are more than welcome to use it if it benefits you. First thing we're going to do is hit install package, and then I happen to have it downloaded, and it is going to be this DXF Importer. So this was developed for the sole purpose of DXF importing, and once you've installed it, it will have you restart robotstudio. So went ahead and hit yes, it'll open right back up. Now, whenever I go into the add-ins tab, we will see this load DXF. Few things to note: if you do not have a robotstudio license, then some of this will not be available to you. So please be careful with that. And if you notice that some of your options are missing, you may need to go in and adjust that and get a license. So from here, I'm going to open up an existing station. The reason I say that is if you try to load the DXF without a station being open, it will fail because you do not have a station open. So I'm going to open an existing station. And then once everything in this station has finished opening, so really I'm going to wait for the controller to start up, I'm going to head over to this add-ins and hit load DXF. Now what that's done is added an extra tab here at the top for manufacturing. Now, before we get a whole lot farther, you'll keep hearing me say DXF, Plasma, and a few other things. This does only work with DXF files saved in the inches format. So, with that said, we're going to create a quick DXF file using Catia. Any DXF file will work. The nuances of your software may be a bit different, so as you guys come across those, just be aware that this wasn't meant to work with everything. It was meant to work with what I use personally. So now that Catia is opened, I'm just going to start up a simple part design. So we're going to add a new part, which is going to be under mechanical design, part design. And part 1 will be perfectly fine. Okay, so for this one, I'm just going to make it simple, and we're going to do a square with 4 holes in it. So the next step is to start up a drawing. So under mechanical design, we can go to drafting, hit OK. And what we want to do is bring over those 2 parts in a 2D drawing. So we're going to click this front view, and while it's active, we are able to switch windows and go to product 1 and select the front face. It will select both of them. With that, now I want to drag the parts to the corner. So this little corner right here is effectively my work object in Catia, or in the robot. So this corner right here is my work object on the robot. That means that if I drag my parts clear over here, wherever I set my work object, the parts will actually be cut out this far away from it. That is extremely problematic because it means that lining up to a sheet is extremely difficult. So we want to make sure we get as close to those edges as possible. That way, whenever I teach the work object on the robot, there's no difficulties. Next thing we're going to do is go ahead and delete this scaling information. The reason we delete that is otherwise the plasma cutter does read it as information. Now, with that said, the plasma cutter does not read open lines to plasma cut. It will only search for closed lines or closed shapes. So notice every one of these shapes inside is closed. Now that we've done that, I can go ahead and save. So File, Save As. I'm going to go to Downloads, and we are going to do this as a DXF. Now, I did mention you have to save in inches, so we're going to call this Plasma Cutting Drawing. If you're just wanting to import DXFs into Robot Studio, then you won't have to worry about some of these steps. So, now we've saved it, we can minimize or even close Catia, and because we've already opened up the DXF add-in under the Manufacturing tab, we can come over here and create a program. So what this will do is it will create a plasma cutting program. Few things that matter for a plasma cutting program is what tool is selected and what Workobjects is selected. Under this Home tab, you can select what task we're referring to, what work object we want to work with. So you'll see I'm actually missing many of the work objects located on this robot, and what tool you want to work with. Now in our case, we will be using the plasma tool. And for that sake, I'm going to go ahead and hide the spindle motor and make sure the plasma cutter is nice and visible. Now, the one I'm missing is I think there should be a work object called plasma cutter in my list, and it is not there. The way I'm going to get it back is synchronize and synchronizing to station. That will bring it from the real robot code over to this virtual 3D world. Work object plasma. Perfect. So we're going to bring that guy in. And just out of curiosity, see where it's at. So he is located on the ground all of the way over here. That'll be good to know later because this is where our plasma cutting will be brought in if I remember to set my work object to the plasma cutting work object. If you leave it on a steel work object or a tool changing work object, it will bring it in relative to those work objects. So I selected T plasma, and we're going to go back to manufacture. Now, whenever you create this program, it will use all of this information you have selected right here. Plasma IO is the digital output on the robot that will be inserted into the program for the robot to turn on and off in its attempt to activate a plasma cutter. Technically, a lot of this could work for things such as a water jet or other similar equipment. So pierce time is whenever the robot first goes down to start cutting and it activates the plasma cutter, it will sit at the start position for a set amount of time in order to make sure that it has cut all of the way through the part, or at least started all of the way through the part. So pierce time, if you're doing very thin metal, 16th, 1/8 inch, sometimes you can get away with a 1/10 or half a second, versus if you're doing inch thick metal, you may need up to 2 seconds or more. So I'm going to set this to 0.5 seconds, assuming I am cutting something like 1/4 inch steel at a high amperage. If you're curious how fast you should be moving and what your pierce time should be, there are many online calculators. Just Google it. Now, the next one is pretty self-explanatory. This is cut speed. Now, you'll notice there are very limited options here, and that is because on the robot, you have a speed dial under the flex pendant. So I'm going to bring up a virtual flex pendant that effectively shows what a real robot would look like and show you where that speed dial is. So after you've used that online calculator to determine how fast you should be moving, you can come in here and set it to a percentage of that speed from 0 to 100 to represent how fast you're actually going to need to plasma cut. So with that said, I would recommend always setting your cut speed to 100 and then running at the exact percentage of that you need to cut at. If you set it for 100 millimeters a second, but you need it to run at 13 millimeters a second, you can set it to 13%. Kerf. Kerf is the offset of the part, or of the plasma path from the actual drawing to make sure that the parts come out the correct size. Now, with that said, a lot of times you only need a 0.5 millimeter or maybe even a millimeter. I'm going to make it 2 millimeters. Now, I want to make sure that I'm clear on how this actually works. This is the offset in one direction. Depending on how you measure kerf, it is the total material destroyed. This is actually referring to half of the material destroyed. So this means I'm claiming that the plasma cutter is destroying 4 millimeters worth of material. That means I have to offset by 2. Now, vertical offset. This is how far away the TCP will be from the surface of the part. So assuming you've taught your work object directly on the surface, 3 millimeters is approximately 1/8 of an inch and will work well for plasma cutting. Now you can go a little farther. Generally with plasma cutting, you're looking at somewhere between 1/8 of an inch and maybe 1/4 to 3/8, but 1/8 of an inch with something this precise often works well. So now that we've added all that, we're going to create a program and select the DXF we created earlier and hit open. Now this does take some time. If you see an issue about something that says not set to an instance of the object, it most likely means that you had a non-closed surface and there was no way for the robot to calculate anything. Now, you will see that I put all of the kerf to 2, and that was so that I could show you just how exaggerated it can become whenever it is moved inward. So, the kerf also pushes it out by that amount. Now, where this is saved is under Paths and Targets, Paths and Procedures. It will create a new plasma path. If you already had a plasma path 1, it will create a plasma path 2. Nice part about robotstudio is it shows me all of the waypoints that are already reachable. So, with that said, I do not necessarily want my plasma cut to happen down here this low to the ground. So, we can come over to the Home tab and select this freehand linear tool to move the entire work object. So what I did there was select the freehand, go to the robot, the work objects, and select the work object I want, and move it closer to where I really want it. This will move all of the targets, but it will not move the drawing that was created. So you will see that this tool does have the ability to import drawings. We don't necessarily need that drawing anymore, but if you want to keep it for reference, you definitely can. So we're going to go back to the manufacturing tab and look at what that path looks like. You will see that most of these motions have a yellow exclamation point, and what that means is the robot cannot reach it in the configuration it is set to. So if we come over here, and this first move, I'm actually going to edit the instruction and turn it into a joint move. The reason I'm turning it into a joint move is it will let the robot swing all of the way around to that point from wherever it is. Now, with that, we're going to modify and change the configuration. Now, configurations are what define how the robot is going to get to a position because it can get to there in many different orientations. I'm going to hide that sander as well so that it is not in the way. Now, if we look at this, the robot can get to the same location in many different ways due to the fact some of its joints can spin 180 or 360 degrees. So, what we generally try and do is select the combination that results in the least amount of joint spinning or the lowest values. So we'll see if I choose configuration 5, joint 3, which is this joint right here, is flipping all of the way over backwards, which is just kind of disgusting to look at. So we're going to go with the one that just requires the least amount of movement, meaning it's typically the most efficient. So I'm going to hit apply. And after I've done that, I can get it to correct all of these paths and waypoints by right-clicking on the path and hitting Auto Configuration All Move Instructions. And you'll see it'll do a quick run through and it'll fix all of the points. Now, sometimes if you have a very large or complicated part, it may not be able to do all of the points, and you may need to readjust where it is or fix singularity issues. You'll see this one didn't have any issues, so we can move forward from here and export to the robot. Now, whenever I say export to the robot, it just means we right-click and synchronize to rapid. This will copy this path over to the rapid section of this robot. So if I go down to our plasma mod, we now have plasma path 1 saved in here. With that said, this code is pretty well ready to run after you've taught a work object on the robot. Now, one thing I do want to add on to this is to show you guys how to delete and entirely get rid of all of the additional information that is imported whenever you create these. After you've done your plasma cut and you no longer need the program, you may want to clean up your model some. So, a few of the things we want to look out for is all of the new parts that are created by this are always called DXF part. So we're going to select all of those and just delete them. The other thing we want to do is delete the existing paths. So all those paths are gone. Now, one thing we do need to watch out for is while the path is gone, all of the individual targets are still there and are rather problematic. So what we're going to do is right click on this TROB1 and hit remove unused targets. And what that will do is actually get rid of all of those targets that we are not using. Now, the last step is we want to get rid of the actual module that was used to create that plasma path. So the reason we want to get rid of that is we want to make sure that the plasma path 1 isn't mixing with the next plasma path that's created. Now, in theory, whenever you synchronize, it should delete this old one, but it's just a good habit to try and keep your code clean. So we'll hit delete. Now, with that, we've created it. So we're going to do this one more time rather fast. So I'm going to set the pierce time to ½ a second. I'm going to set the kerf to something much more reasonable for something we would cut. Hit create program, select my file, and hit open. It will now create that path. I will make sure everything's nice and happy with it. I'll look at it. I need to change that so it has the correct configuration. Now, technically, the code will play without changing this configuration because we have this conf-L and conf-J off, but it's best to make sure that we know what it's actually going to do. So we want to make sure it can reach everything, and that's a very quick way. Let's go ahead and set this as the synchronization point. So set a simulation entry point. I'm going to go ahead and synchronize to rapid while we're at it. I can either click here and hit play or go back to my simulation tab and hit play. And now we can watch it run through. We'll see that my simulation is running in real-time speeds. Once again, you will most likely be running at a percentage of the 100 millimeters a second program. But for functionality and making sure everything will behave and getting a guesstimate for how long this might take, you can do this right here without a problem. Now, one thing I want to bring up here is you will see the robot going through and cutting holes, and rather than being the most efficient possible, it does tend to bounce around a lot. In theory, you could optimize this path. Now, there's 2 reasons that this path is not optimized. The first of which is because the heat buildup in a part, if we locate that to one spot continuously, it'll make the warping in one location much worse and then possibly throw off your plasma cutting as you go. The other reason is that I am a poor programmer and it just happens accidentally that way. But it sounds like a great excuse whenever I explain it like that. So with that, last thing we want to show is that you can save the code. So I'm going to right click on this plasma module, hit save module as, save it to my downloads. And now I can put this on a USB stick and load it on a real robot. For people who are not familiar, loading onto a real robot is as simple as copying this file right here onto a USB stick, going to controller. I'm going to pull the fake teach pin up just to show you what it might look like. I'm going to turn the robot into manual mode so that you can see what it would look like. I do recommend only ever running this in manual mode until you have verified everything is perfect, because plasma cutters are not meant for 100% duty cycle most of the time, and also just because this is a hazardous thing, so you want to make sure you have an e-stop in hand at all times. But we're going to go to Program Editor. We will go to Modules, File, and Load Module. And now we can navigate to, if we had a USB stick, we would scroll up. And you'll see, because I'm actually on a virtual controller, I can actually go quite high in my folder structure. But at one point, you'll see a USB option, and you'll be able to select that and continue from there.